Hello friends, today we are going to continue the part 1. Here the topic number 7 electronics communication and the part 2 will going to get discussed here. So you can see last time we have discussed something about basic of modulation. Now we'll continue the similar topic but a few of the other parameters. So here the parameter is power and bandwidth. You can see here power and bandwidth. Power in communication refers to the energy carried by the transmitted signal. Higher transmitted power increases communication range. Here you can see in this graph. This graph is of a frequency domain graph where this horizontal axis is shown frequency. This Fc shows carrier frequency and this Vc is nothing but an amplitude of that particular carrier wave. This is a voltage. And in that, if I talk about this one, bandwidth is the range of frequencies required to transmit a signal without distortion. So if we talk about FAM, amplitude modulated system, amplitude modulation, in that one bandwidth, this BW where AM stands for amplitude modulation equal to 2FM. FM is nothing but a frequency of message signal. Here you can see in this diagram this bandwidth equal to 2FM. This diagram represent AM modulation system, that is AM for amplitude modulation system. Now if I try to find the bandwidth, this higher frequency minus this lower frequency, I'll get this equation bandwidth equal to 2FM. Likewise, we can also able to find the value of FM bandwidth. Now here you can see here just the equation of bandwidth of FM frequency modulated signal is shown. That is equal to 2 into bracket delta F plus FM bracket over, where delta F is frequency deviation. The efficient use of bandwidth is crucial because of the frequency spectrum is limited. So we have to always utilize this spectrum wisely. Now if I say about applications of this power and bandwidth, that applications include spectrum allocation, designing transmitters or receivers, mobile communications, optical links and TV broadcasting. Now let us go for the further one. Now I'm going to discuss here types of modulations. Basically you can see this diagram. In this diagram the modulation is classified into two parts. This one is analog and another is digital. We are not going to discuss much about digital in this topic. We'll more focus on this analog part. So analog modulation is classified in basically three parts. One is AM amplitude modulation, another is FM frequency modulation, and third one is nothing but PM, that is known as phase modulation. So AM, FM and PM, these three types are considered under the analog modulation. So digital modulation uses discrete symbol. Just I am giving you just a brief highlight of digital modulation. So digital modulation uses discrete symbol based variations such as ASK, FSK and PSK. As we know, this AM, FM and PM, likewise A, F and P are common letters in this one. So this A stands for amplitude, S stands for shift and K stands for keying. Amplitude shift keying, frequency shift keying and phase shift keying. These three terms are used in the digital modulation. The choice of modulation depends on noise, performance, bandwidth, availability and applications. So this is about digital modulation. Now let us discuss basic of each and every modulation type. AM is used for standard radio broadcasting, FM for high quality audio transmission, PSK or FSK for digital communication, and QAM, that is a quadrature amplitude modulation for high speed data application like Wi-Fi and LTE. So this is just a basic about types of modulation. Now let us go further. Here I am going to discuss about an analysis of amplitude modulated wave. So amplitude modulated, here you see the term amplitude. Amplitude is a key word over here. So an amplitude wave consists of a carrier signal whose amplitude varies with the message signal. So you see this is what our message signal is and this is what a carrier signal. So the message signal is not able to travel a longer distance, so that we need some signal which is having some high power value, and that signal we mix this message signal with this carrier signal using a modulation technique that is known as amplitude modulation, and we are getting amplitude modulated signal, where you can see the output signal where its amplitude is different at each and every point. This amplitude is also different. If you see this one and this one, the output of combination of both of these signal, we are getting difference in the amplitude, but the frequency inside this one, the frequency is not changed. You can see the frequency of carrier is similar in the signal, but the amplitude of the signal is varies. So based on this is known as amplitude modulation. So expanding this gives us the carrier and two sidebands. So USB and LSB. USB stands for upper sideband and LSB stands for lower sideband. Here you can see the signal that is S of t. S of t is nothing but amplitude modulated signal. So this is a mathematical representation of that signal. This is what that signal is, and that is AC into bracket 1 plus small m cos omega t and bracket over, and it is whole multiplied with the cos omega c t. This omega m there is related with the message signal, and this omega c that is related to carrier signal. So wherever you see this small c, that is related to this carrier signal, and wherever you see the small m in this equation, this is nothing but related to message signal. Now let us discuss a little bit about what is that sidebands. So the sidebands contains the actual information. I'll discuss this in upcoming slide. So the modulation index, this small m, determines the depth of modulation and must satisfy the condition 0 less than m less than or equal to 1 to avoid the distortion. So we have to maintain this modulation index that can be found using this minimum amplitude and maximum amplitude level. That equation is different. We are not discussing the equation of this modulation index. So this is just a basic about amplitude modulated wave. Now another thing, the applications of amplitude modulation. This amplitude modulation include AM broadcasting, aircraft communication, and public communication system. Now let us go further. Now this is about sideband frequencies in AM wave. As in last slide, we have discussed about lower sideband and upper sideband. So I'm going to show you just a brief highlight about what is actually a sidebands are. So sidebands are produced due to frequency mixing of the carrier frequency Fc and modulating frequency Fm. They occur at F USB equal to Fc plus Fm and F LSB equal to Fc minus Fm. You can see this is a center frequency. This is actually a carrier frequency. Fc is a fixed point where you can when you mix this message signal and carrier signal, that is by using modulation technique. Here we have discussed about AM modulation. So you'll get these two sidebands, this lower sideband and this upper sideband. This is because of mixing of the frequencies. And that lower sidebands, you can see this lower side is Fc minus Fm. This one lower sideband is Fc minus Fm, and upper sideband that is Fc plus Fm. So both the sidebands are nothing but it is containing some information. So these sidebands carry all the useful information while the carrier contains no new information. So understanding this sideband is essential for designing AM transmitters and receivers, SSB single sideband systems, and spectrum efficient communication. I hope you understood a little bit about these sidebands, these amplitude modulations, what is analysis, what is that actually what is happening to this waveform. Basic equations are just discussed. More depth you'll understand in further subjects. So thank you very much. This is all done for this part. We'll continue the upcoming topic in part number 3. Thank you very much.